Hey guys, want to talk about this upcoming homework problem. It's the limit as x equals 4 of x minus 4 over x squared minus 3x minus 4. If you put the 4 on top and the 4 on the bottom and simplify it, you're going to get 0 over 0, which means we have a problem. Now, since it's a binomial on top and trinomial on the bottom, I think we could factor it and then try to substitute in that 4. But while you're trying that, let me show you the new way we're going to be solving this stuff. We're going to make a table of values. Let me pull it back a little bit. That means that my x values are on top, and I'm looking at every single thing that's happening around 4. So I'm looking just before 4, a little bit close, a little bit farther away, a little bit farther away, and a tiny little bit afterwards. All I want to know is where the function is going around that 4 value. So there's no way I'm going to calculate all of that in my head because I'm on vacation. It's Rosh Hashanah. So let's make the calculator do some work. So here we go with a beautiful TI 84 plus. Let's go to y equals. Nice nails, huh? Now, I guess it helps turn on the calculator, and jackpot, here we are at y equals. I put in my function. Now it's a fraction, right? So x minus 4 is in the top, closed up with parentheses, divided by the bottom trinomial. That's x squared minus 3x minus 4. If I want to look at the graph, I could hit the graph button and see that it's pretty normal. But I want to know what's happening around the number 4. And look, even no matter how close I zoom up, it just looks kind of straight. So let's really check it out by hitting second and table. All right, so hey, check it out. At 4, there's an error. But you see those x values? None of them match the x values that I want. I want to look just before 4 and just after 4. I want to look real close. In order to do that, we're going to have to set up our table, and this is why I want you watching. Okay, check it. We're going to hit second and then F2. That's table setup. So second is here, table setup. Now, it tells me where the table is going to start. Here, I'm starting at 0. And see that little triangle in front of the table equals 1? Well, that tells me what the change in the x value is going to be. So if I look at it at every 1, I'm going to be taking x is 1, x is 2, x is 3. Let's make it really fancy. Let's look at it at point, let's look at every 10 cents. All right? Now let's go back to second table to check it out. Now look at how it's different. I got point 1, point 2, point 3. It's getting really close. But it's still not exactly what I want to look at. And again, I'm pretty lazy, so if I go back to second table setup, instead of point 1, let's go point 001. Because point 001, I think, yep, is the closest we're getting. And where do I want my table to start? Because if I just go, let me show you, back to second table now, I gotta scroll through a million values to get where I want. I'm not doing that. So second table setup. Oh, check it. When I scroll down a little bit, it went exactly where I wanted. So if I want to evaluate the x value at 3.9, how about I just start it at 3.9? All right. So I'm starting at 3.9, the first x value that I want, and the change is still tiny. It's 0.001. So I can go back to second table. I got a big old number here. It's a decimal, and that's fine. It's 2.0408. Now, don't mind the expo. Let's just get up here, like my whiteboard. Here we go. When x is 3.9, f of x is 0.20408. If you factored the equation and used substitution, you might know if we're heading in the right direction, but the next value I have to check on is 3.99. Okay, back to handy dandy calculator. I could be scrolling down forever, but I'm not doing that. So I'm going to go to second table setup, and I'm going to go right where I want to look at, 3.99, but I don't want 3.988, 3.990, and second table. Cool. 0.004. I'm sorry. 0.2004. Yep, that's the right one. All right, I still got to check out $3.99 and 9/10 of a cent. So back to my calculator, and I could scroll down forever. Actually, it's not that far. It's only 10. Oh, here we go. 0.2 zeros and a 4. 0.2 zeros and a 4. Oh, half my homework problem is done already. Now, got to go for ones afterwards too. That first one will be easy to scroll to. Hope you're not getting motion sickness from my video recording. There we go. 0.19996. 0.19996. Hey, before it went, it was up but a tiny bit. Now it's down by the same tiny bit. I bet you I know what the next number is going to be. Next one I want to look at where x equals second table setup. I want to find out 4.01, $4.01. So 4.01 and second table, 1996. All right. I was in my junior year of high school, trying to stay as far as I could away from math in 1996. I'm glad you're not there. Last one is $4.10. We're just going to check that out. So the homework problem's done. So again, second table setup, and I want to look at 4.1. Yeah, I don't want 11, so I might as well make it a 0. Go second table, 0.19608. All right, I got it. 0.19608. All right, so haha, I finished like your first homework problem for you. Shame on me, bad teacher. The question mark in the center is going to say what the function's approaching. And I know what it's approaching because while I've been doing all this work, I also magically factored it, finding out that x minus 4 on top and bottom cancel out, leaving 1 over x plus 1, taking the 4 and putting it in there just gives me 1/5. And I'm a fraction queen, so I know that's equal to 0.2. So if you remembered what I taught you on the first day of school, you kind of solved this without doing any of that table work. But it's important so we can evaluate it because, you know, let's look at it. This is kind of important. You see that graph or the picture that's making? It's got some stuff. Like over here, it's got a vertical asymptote. But where the function is 4, you know, you really can't see what's happening. We saw it on the table. And let me just draw this just so we have a nice pick going down and then a little bit before going up. 1, 2, 3, 4. I want to show you exactly what's happening here. All right. Where x equals 4, right here, there's a hole. Yeah, there's a hole in the function. It's one tiny little spot on the whole graph where the function is not defined. There's not a y value for it. But limits, as I'll tell you in class when we get back, limits are not just the y value. I might have been oversimplifying. This has been 8 minutes of probably utter pain for you, so I'm going to leave you to go back to playing video games. This is one of the problems from your homework. You probably won't cry. Watch this video and share it with your friends so you'll all know way too much math. Thank you.